Hello students. So now in this lecture we're gonna start with a new chapter. So the name of the chapter is linear programming problem. In short we can say LPP. And basically the chapter, it is very easy and interesting, and we'll divide this chapter into two group as it contain 2-3 exercise. We'll divide 2-3 exercise into two group, or else we can say two types. Type number 1 graphical method and type number 2 formulate LPP. So here what do you mean by graphical method? Graphical means what? Like this you will have two linear in equation. So why I am saying this as a linear in equation, as the power of the variable is 1, the power of x and y, here also the power of x and y, it is 1. This two equation, it is treated as inequation, linear inequation. Why it is treated as linear inequation? Because when you will see here equal to symbol is not there. If in place of less than equal to, if equal to, this equal to symbol is there, then only we can say it is a linear equation. So from this we come to the conclusion that, so in this chapter, the graphical method, in graphical method we will be dealing the sums with respect to linear inequation. I hope you all understood what do you mean by inequation. Inequation means what? Equal to sign will be replaced by less than equal to, or sometime it will be replaced by greater than equal to. So that's why it is known as linear inequation. Okay. So now graphical means what? You will have two linear inequation. You will plot the point. You will draw the graph. Okay. So that is known as graphical method. And second one is what? Type number 2 formulate. Formulate means what? A given equation, it will be in the form of statement sum. You have to read and understand the question, and simply you have to frame the equation like this. You have to frame the equation, read, understand, frame the equation. That's it. It means formulate. Formulate means simply you have to read and understand the question and you have to frame the equation. That's it. If in question, if it says that you have to formulate and as well as you have to draw the graph, then you will frame the equation and then you will draw the graph also. So we'll divide this whole chapter into two type. We'll consider the type number 1 as graphical method and type number 2 as formulate the linear programming problem. Okay, so let's begin with the graphical method. So now before dealing with this concept of type number 1, first we'll see some small things which we have to learn before dealing with this graphical method. As I told that we have to deal with a linear inequation, not with the linear equation. Okay, so whenever the equal to symbol is replaced by less than equals to or greater than equal to, it means it is a linear inequation. Now in graphical method, here in the bracket I had written to show that feasible region. Actually the graphical method is based on to show the feasible region. Now what do you mean by feasible region? In simple language I will say it is known as the common portion or common region, or else I can use the word shaded common portion. So basically the graphical method where you have to show some common portion or a common region, or in simple language I will say that feasible means what? You have to draw a shaded region. Now exactly where we have to draw the shaded region, so that is the important point. Okay, so here the challenging part for the graphical method is what? The plotting point part is very simple. Plotting the graph, it is very simple. The challenging part is to show the feasible region. So what do you mean by the feasible region? Is it means we can say in simple mathematical language, common portion, or else we can say the shaded region. So here, after drawing the graph, after plotting the graph, you have to show the shaded region. That shaded region will come this side also, here also, this region. The shaded region can come here also inside, or this side also. So here the challenging part is what? To show the feasible region perfectly. If your feasible region is perfect, then you will get the perfect answer. And if the shaded region is in the different partition, you will get a wrong answer. So here the whole and sole sum, it is based on the proper shaded region, or else we can say the common portion. If you are getting the common portion perfectly, then you will get the perfect answer. Okay, so now first, I hope you all might be knowing this two word, at least, at most. At least means what? Greater than equal to. At most means what? Less than equal to. But in this chapter, this two word will replace by minimize and maximize. You will not see at least and at most. Here in this chapter, you will see minimize and maximize. So whenever it comes minimize, it means minimize means at least, and maximize means at most. Remember this. Minimum means at least and maximum means at most. That means for at least and minimum, the symbol will be greater than equal to, and for at most and maximum, it will be less than equal to. Got the point? So this is the main point which you have to remember in this topic. Okay, so now after that, after plotting the graph, you have to show the feasible region, yes or no. Now here I will show some int, a technique we can say. Suppose here we have two equation, yeah, more than two equation, more than two equation. So whenever you have a two linear inequation, more than that, if each and every equation contain a less than equal to, less than equal to, always remember the feasible region, the shaded portion will come inside. Always it will be inside only. Okay, so remember this technique. Whenever it is less than equal to, the shaded portion will be inside, touching to a origin. Okay, whenever it is greater than equal to, okay, so the shaded region will come this side. So here I will use the word non-origin, as this shaded region is not touching to the origin, so I will use the word non-origin, and this I will say origin, as here the shaded region is touching to the origin. So this is known as what? Origin, 0 comma 0. Yes or no? So remember this two technique. So whenever a equation contain less than equal to, always and always the feasible region will come inside. Whenever it is greater than equal to, it will come outside. So for this I will use origin, and this I will use non-origin side. Okay, so here we got the idea. So remember, whenever you have a two linear inequation, okay, and it contain less than equal to, for each and every equation, always and always the feasible region will be inside. Okay, and suppose if particular equation contain whether we have two equation, two linear inequation, yeah, more than that, and the symbol for this is less than, greater than, equal to, whether we have two equation or more than two. See to it that for this types of sum, when it contain greater than equal to, so the shaded region, the feasible region, will be always outside. Okay, so remember, whenever it is less than, okay, remember this point, a particular equation should contain same symbol, less than, then the shaded region will be inside. When it is greater than for two, yeah, more than two linear inequation, so the shaded portion, the feasible region, will be outside. So here I will use the word non-origin side, and for this I will use the word origin side. So remember this trick. Okay, two important point I can say, whenever it is less than, okay, the common region will be inside. Whenever it is greater than, the common region will be outside. Okay, so here we'll see now, as clearly we can see that here we have two linear inequation, and both the equation contain less than equal to means what, the shaded portion, the common region, will come inside. Why so, sir? Is it technique, or there is a concept, a proper concept, that we have to draw the shaded region inside only? Actually there is a proper concept that now I will explain. So so here we have two linear inequation. So this line will consider as first one, and this will consider as the second equation. Okay, now what is the proper concept? I will explain. This was the indent technique now. So now we'll see the proper concept. Now for the first equation, so can I say that this is the first equation, equation number one. For equation number one, the first equation, what is the symbol? Less than. So can I say, if it contain only one line, so where will be the feasible region? This side, na? This side. That means this and this region. Okay, this two region. Now we'll see the second. For second equation, can you see the second equation? This is the second. Okay, this is the second. For second also, suppose it contain only one line. So for this line, so where the shaded region will come? This side. Can you see? For this one, this two region will come, and for this section, this two region will come. So here clearly can I say that for this two equation, linear inequation, when it contain less than equal to, so the common region, the common portion is what? Actually this one. This is the common portion. This common portion, actually it is known as what? Feasible region. So what do you mean by feasible region? The common region between two or more than two equation, yeah, linear inequation, is known as feasible region. Got the point? Once again we'll see the first one. Okay, for the first equation, this two region will come. For the second equation, this two region will come. So where is the more point of intersection of the shaded region? Can I say this side? Okay, and the shaded region is touching to the origin side. So this is the origin side. Okay, and outside the region, this is known as non-origin side. So that's why I told, so remember this trick, whenever a equation contain two or more than two equation, and the symbol, if it contain less than equal to, okay, for that types of sum, always and always the feasible region will be what? Inside only. Okay, so this was the trick, and this was the proper concept. Now we'll see for this second one. Here clearly we can see that the symbol is greater than equal to. So we'll consider this as first and this as second. Now we'll see where we will get a proper, a common portion, a common region here. We'll take the help of scale here now. So this is the first one. First, so for the first one, what is the symbol greater than equal to? So for the greater than equal to, we know that shaded region will be what? Outside the line. So this part will come, this region. Can you see this one? This and this region will come for the first equation, this two. And for the second, again it is greater than means what? This and this region will come. For the first one, this two were there, this part and this one. And for this equation, it is greater than means the shaded region will be this side. So here clearly we can see that the common portion is what? This section. Yes or no? For the first one, it was this and this. Yes or no? And for the second one, yes or no? For the second one, this and this, and for first one, this and this. So clearly we can see the common region, the common point of intersection, shaded region is where? It come this side. So that's why I told, remember this trick. Whenever we have a two, yeah, more than two equation, and if it contain less than equal to, always and always the shaded region will be inside, and when it contain greater than equal to, the shaded region will be outside. So this is known as non-origin side, as it is not touching to the origin, and this is known as origin side, as the shaded region is touching to the origin. Okay, so now we'll see, sir, if what, if one equation contain less than equal to and another contain greater than equal to, again it is simple. Okay, now again same. First, we'll consider the first line as first equation, this one, x plus y greater less than equal to 6, and this is second, 2x plus 3y greater than equal to 12. Okay, now for the first equation, we'll see where will be the shaded portion, your feasible region, we can say. Clearly we can see that less than means what? This is the first. Less than means what? This two region will come. Yes or no? Understood? This two region will come. And for the second equation, clearly we can see that this and this will come, as it is greater than. Greater than means what? The shaded region will be outside this line. Okay, so this and this region. Okay, so for this it was this and this, and for this and this. So here clearly we can see that the shaded region is this side. Understood? So in this way, this is the proper concept. With the help of the scale, you can see that where the common region will come with the help of scale. Got the point? Okay, so here we can say there are three types of sum, where you will see two or more than two equation contain less than equal to, two or more than two equation contain greater than equal to 2, greater than equal to, two or more than equal to, or two or more than equation will contain less than or else greater than. So in graphical method also there are three types, one based on less than, one based on greater than, one based on less than and greater than. It will be together. Okay, now one more point. So here they will use one condition like this: x greater than equal to 0, y greater than equal to 0, means on the right hand side you will have 0. If you have the numbers, it's okay. Whenever you will see in any equation this condition like this, okay, x greater than equal to 0 and y greater than equal to 0, actually it is not a equation, it is a condition. Actually remember this as a condition. So what do you mean by this? It means what? X greater than equal to 0 means what? The value of x will be positive. Y greater than equal to 0 will be what? That means the value of y will be greater than 0 means what? Positive. So here clearly we can see x and y both are what? Positive. So if both are positive, the coordinate of x and y, where does it will lies? It will lies in the first quadrant. So that's why here, for while explaining the example, I took only the first quadrant. Can you see this is the first quadrant? First. So here I will say in exercise you will see majority of the sum it is based on the first quadrant only. There are 2 3 sums where you will see that you have to consider the second quadrant as well as third also, but here I will say 99% of the sum it is based on the first quadrant. No need of taking the second, third and fourth quadrant. When you will solve the sum, okay, so while solving you will get the value of x and y as positive only. If you are getting the positive values, both will be positive, then it will lies in the first quadrant only. Remember this. If the condition, this condition is given, no need of thinking much more. That means this condition means what? Always it will lies in the first quadrant. In case if the condition is not given, now it's depend on the question. If you are getting the negative values, then we have to think that we have to consider the second, third, yeah, fourth. Okay, but here I will say it's my survey that majority of the sums it is based on the first quadrant only. So this was the basic concept of the graphical method. Okay, formulate it is very simple, just you have to read and understand the question and just you have to frame the equation. That's it. And graphical method it is very important, as each and every sum in the exercise it is a proper 4 mark sum, not less than that. Okay, so these are the points which you have to remember. And here the challenging part is what? To show the feasible region. If your shaded portion, a common region is perfect, then you will get the perfect answer. Otherwise the final answer, if the shaded region is different, in place of here if you are drawing the shaded region somewhere else, straight away the answer, the final answer will be wrong only. So here I will say the challenging part is what? To draw the proper feasible region. Okay, so now we'll see one sum based on maximize, one sum based on maximize. Okay, then maximize means less than equal to, we'll see one sum based on less than equals to. As here clearly we can see that here we have two linear inequation, and this is not a equation, actually it is a condition. Remember, whenever the right hand side it contains 0, okay, don't consider this as a equation. Okay, consider this as a condition. These two are the equation. So one based on less than equal to, one will see based on greater than equal to. Okay, one sum based on less than equal to, one based on greater than equal to. So when I say how many linear inequations are there, so you will say two linear inequations, yes or no? And what about these two? They are the condition. That means our plotting will lies in the first quadrant. That means we have to consider only the first quadrant. And then we'll see one sum based on less than and greater than. Okay, so in the first equation, in the first sum we saw, we'll see for less than equal to, and in the second sum we'll see for greater than equal to, and in the third sum we'll see less than and greater than together. And we'll take the fourth one where you will see more than two equation. More than two equation. Understood? Okay, so in this way we'll divide the graphical method. Understood? Got the point? So let's begin with the sum number 1 now.